All right, so we're solving for a geometric sequence. We're just going to find the ratio and the starting value. And if the problem had required us to go further with it, we could. But with the starting value and the ratio, we can do quite a bit. Now, first off, this is non-consecutive, meaning that the information that's given is these values are not next to each other in the table. There's a gap in between them. This is the third number is 20 and the 14th number is 40,960. And so we're going to figure this out. Now, the equation that's going to help us do this is the sequence equation for geometric sequences. The first term times the ratio n minus 1 times. So if we use this information, our knowledge that the third number is 20, and we plug that into this blue equation, we will get something useful. That would then be 20 is the third term, and we don't know u1, so we'll just leave it u1. We also don't know ratio, but we do know that the third term would be 3 minus 1 is 2. The ratio would be multiplied 2 times. Okay, we'll leave it at that and do the similar process to u14. The 14th number is 40,960, and still don't know the first number or the ratio, but we do know that the exponent would then be 13. Okay, these two together, we can solve this. This is like a system of equations, but there's no addition or subtraction in this problem, so the process is a little different. We're not going to add or subtract them creatively to eliminate a variable. Instead, we are going to divide them. And this one's bigger, so I'm going to put that one on top. It'll just look nicer as we move through the problem. u1 times r to the 13th. Okay, and we're going to divide both sides by 20. So notice this 20. So over here, this side of the equal sign is 20. And over here, we're going to divide by what is equivalent to 20, which is the u1 times r squared. So dividing the left side by the left side and the right side by the right side. And that's okay to do because we're dividing both sides by what is the same value. This is 20 and this is equal to 20, just expressed differently. So we're not changing the overall equality. We're okay to do that. What happens, u1 divided by u1, is those factors will cancel, and then we only have r in the problem, which is the purpose of this step. Left-hand side, we'll just quick calculate this, 2,048. And then the right-hand side, you have to remember your exponent rules when you divide like this. 2 of the r's will cancel out off of 13. In other words, subtract the exponents to make 11 r's remain. And from here, we need to solve. And a couple people, if you like the root, we're going to take the 11th root of both sides. However, I'm not going to do the root approach. I'm going to instead use a fractional exponent. So this right here, the exponent is 11. If we wanted to cancel that out or undo the 11th power, we would use the 1/11th. We would reciprocate this, and since it's 11 over 1, the 1 over 11 will undo that. And the reason being is that when we have a power to a power, we multiply these. And so that would be, when you multiply fractions, you multiply top to top, bottom to bottom. So it's just 11 over 11, which is 1. And if we drop down and rewrite what happens here, that would be r to the first power, or just r. And then we have to go ahead and calculate this. And so we'll go ahead and do that very carefully here. 2,048 to the 1/11th power is 2, which means our ratio is 2. We'll go back and plug that into one of the equations, and I'm going to use this one because it looks much easier to use. So if we plug in r is 2 into here, it would read 20 equals u1 times 2 squared, or 4. And then if I rewrite that, that would be 4u1. Generally write the number, the coefficient in front of the variable, and then divide both sides by 4 and 5 and get u1 is 5. So we found the ratio in the U1. If we wanted to then further the problem and do something else with this information, we could use the equation with our specific numbers plugged in, 5 times 2n minus 1. So that is useful if the problem continues on.